Welcome to the March 2016 OEM Australia Server Update. In this update, we'll be focusing on Windows Server 2012 R2's Hyper-V capabilities, especially in regards to the licensing and the capabilities that you get with Windows Server Standard versus Data Center editions. So we'll be talking about these from a technical perspective and then from a licensing perspective, then introducing some different virtualization scenarios that may not have been part of the conversations that you've been having with customers in the past. Let's start off with improvements to virtualization and some of the underlying technology. So a lot of these will be improvements that have occurred with Hyper-V itself, but then we'll also talk about some of the storage and networking improvements that have also been made to Windows Server. So first up, as we take a look at some of the enhancements to Hyper-V itself, some of the big changes we've seen over the evolution of Hyper-V and Windows Server are the changes that have been made to dynamic memory. So some of the enhancements that we've seen in recent versions include the minimum and startup memory changes, enhancements to smart paging, memory ballooning, and runtime configuration changes. So let's jump in and take a look at some of these. So first up, we can take a look at things such as the ability to go through and increase the maximum amount of memory available to a virtual machine without a restart. So this is something where if we've got a workload that for whatever reason does require more memory than we've currently got allocated to it, we can go through and assign more memory to that VM without restarting it. Now, what we have to take into account here, obviously, is that there has to be available memory on the server itself. So the Hyper-V host has to have that server available, or other virtual machines need to be in a situation where they can release that memory and make it available. Now, other changes that have been introduced with Windows Server 2012 R2 was the ability to go through and start using what's called smart paging. So with smart paging, it's something that kicks in a particular scenario, and that scenario is that if a virtual machine is restarting and it finds out that there's not enough physical memory available, it can then start using some of the physical storage that you've got set aside to act as virtual memory for that VM while it starts. So it's not something that's going to be sitting there running a VM out of that virtual memory for the entire period that that VM is running. We know what the consequences would be to a virtual workload if it's basically treating a hard disk as a swap file instead of using real memory. So instead, it's just something that it will use temporarily while it's getting started, and then it will go through and stop using it and start using the required amount of system memory. So there are really, the three things that really are required for this feature to kick in, because obviously it's not something you want to rely on, is that the VM needs to be restarted. So if you're starting up a cold VM, so booting it from scratch, this is not going to kick in. If there's not enough system memory, there's not enough system memory for this VM to get started. So the physical memory isn't available, and then the other VMs can't release or won't release the required memory in time for that VM to restart. In that case, that's when these are really the required conditions for this to kick in and work. So once it does start up with Hyper-V paging, this is one of those things where you need to think about, okay, what's the performance of the disk subsystem going to be? Is my disk subsystem already overworked? Is that going to have an impact on this? So these are some of the things that you can read a lot more details about up on the TechNet documentation site. But this is just giving you a quick introduction as to what some of those capabilities are. And then as soon as that machine does restart, that paged memory that was used does get removed from the VM. Now, some of the changes that were introduced with Windows Server 2012 and then enhanced with Windows Server 2012 R2 were some of the live migration scenarios. So in this scenario, you can see that we've got two Hyper-V hosts at the top. Currently, we've got the VM sitting over on the left-hand side and the target host without a VM on the right-hand side. But at the bottom, we've got the shared storage, and the shared storage can be SMB3.0, it can be Fiber Channel, it can be iSCSI. And what we can do here with a live migration is we can go through and initially establish that connection and say, I want to move that virtual machine across. So the first thing it does is copy the configuration data across, but then it will start copying across the memory pages and starting to get everything so that it's in sync, so that it can then switch across to start using that target host to run the virtual machine. Now, what you can see here is that there are really three pieces to this solution. You've got that shared storage at the bottom, and by using the shared storage, it means that the virtual hard drive or VHD or VHDX file doesn't need to travel across the network during that migration. So if we're talking about a VM with a couple of gig of memory, or maybe 4, 8, 16 gig of memory, to transfer that across a high-speed network really isn't that that big a demand on gigabit plus type networks. Whereas if we had a 500 gig or a 1 terabyte virtual drive, obviously that's going to take a lot longer to occur. So this scenario is a very, very fast scenario, but we can also do it without that shared storage. And this is called a shared nothing live migration. And with a shared nothing live migration, what it means is that we've got the ability to go through and copy everything from the VHD/VHDX file onwards across the network, along with the in-memory contents across to that second server. So lower hardware requirements, but much more bandwidth intensive, and definitely it is going to take a lot longer to occur. Now, other things that can take place during this is that we can have multiple live migrations. We can move the slider, set the number in terms of how many live migrations we want to occur at once. If we've got the bandwidth and the disk subsystem to support it, we can bump it up to more than the default, which is set to 2. Now, other things that occur here is that if it's a gigabit connection or a 10 gigabit connection or slower, it will go through and compress the data as it pushes it across the wire. So that way we can leverage any underutilized CPU processing to push content across the network faster, because we can compress it. And generally we're talking about a 2 times improvement in performance there. So to finish off the animation here, you can see that once the modified memory pages have been pushed across and everything is synchronized, we switch across to the target host, and effectively we can start up from there, or effectively we are switched across to there, and from an end user perspective and from a workload perspective, it's all seamless and transparent. Now, there have also been changes to storage live migrations. So in the last scenario, you saw that we needed to change the Hyper-V host that we were connecting into. In this case, we just want to move where the VHD or VHDX files are located. And here we see source device and target device as where the VHD files are located. Okay, these could be local, they could be on the network, it could be 2 drives within the same server, it could be 2 drives or 2 shares across the network. And it's just a matter of saying, well, for whatever reason, we need to move it from here to here. So it could be that you built it out in a test environment and now you need to move it into production. It could be that a workload requires more IOPS than the current disk subsystem can provide and you need to move it. So this is a very easy way for you to go through and do that movement. So the way that this one works is, in the last one we saw that it was the in-memory contents that got transferred. In this case, you can see that it's the disk contents that are getting transferred from point A to point B. And once it gets to the point where those are synchronized, it will then start writing to both VHDs at the same time. And then once everything is in sync, it will switch across to that target device, and the virtual machine just keeps on running. And again, no impact to the users or services that are leveraging what that virtual machine was running. Hyper-V Replica was introduced with Windows Server 2012, and what it provides is the ability for you to either push a replica of the Hyper-V storage from server A to server B, perhaps in the same network location, or even across network locations. So in this case, you can see that there's a primary site and a replica site. So this way, if anything goes wrong, they can start those virtual machines up in the replica site with the most recently synchronized copy of the virtual machine updates that were pushed across. So what's important with this is, don't think of this as high availability, because high availability is generally more of a clustering type scenario where you've got multiple copies of a workload running at once and you can quite easily switch from one to another. In this case, the VHD or VHDX files, or the virtual machines, they're not powered on in the remote location. They're only powered on at the primary site. So you'll need to take into account how much time, for example, it's going to take to spin those up and get things up and running. So this is configurable in terms of 30-second, 5-minute and 15-minute intervals. Obviously, your bandwidth is going to play a big role in terms of what setting you choose there, in terms of how frequently you want the replication to occur. And this is something that is very, very easy to set up. You just use Hyper-V Manager to take a look at that. If you haven't seen this, I strongly recommend you take a look through some of the other videos on the video channel where we do some where we've got some video content demonstrating how these pieces work. Now, an enhancement that was made in Server 2012 R2 was the ability to use extended replication. So with extended replication, what you can see here is that we've got the primary site, the replica site, but we've also added the disaster recovery site. So the primary and the replica site might be both inside of our network. When we get to the disaster recovery site, this could actually be a hosting provider that we work with, where we say, look, we want to replicate our virtual machines into your environment. So this starts changing parts of the conversation here, because inside your network, you might be doing all of this using things like Active Directory-based security. But as soon as you get into working with a hosting provider, you're probably not going to be part of the same domain that they are. So this is where you need to start talking to them around having the appropriate certificates, etc., in place to be able to go through, establish the trust, and allow these to take place. But again, this gives you that ability to go through and fire up in one or the alternative disaster recovery site if you do have issues with your own network infrastructure. Moving over to some features that aren't specific to Hyper-V but definitely enhance some of the Hyper-V capabilities. First up, we've got NIC teaming. Now, the big benefit that NIC teaming provides Hyper-V is the ability to go through and start simplifying the number of switches that get exposed out to the virtual machines, but it provides functionality all the way through the operating system. And the reason why it's important that this is a Windows Server feature now is that it means that Microsoft supports it. Microsoft has written this. So instead of relying on third-party solutions that may have ties to third-party specific switch vendors, for example, this is all very, very hardware agnostic. So it doesn't matter what NICs you're using, it doesn't matter what switches you're using or what network infrastructure you're using. The NIC teaming functionality is something that Microsoft has designed to really work across a broad variety of environments. And what NIC teaming will do is across all of the different networking protocols that run on top of Windows Server, it gives you load balancing capabilities, it gives you failover capabilities, it gives you the ability to team up to 32 network adapters, you get bandwidth aggregation. So if you really need to start scaling out, if you need to start providing multiple paths to get from point A to point B, this is something that NIC teaming can do for you. Another area of networking that was improved drastically with Windows Server and Windows Server 2012 R2 was SMB multi-channel. And in this slide we'll talk about one specific feature of SMB multi-channel, but I'll cover a couple of others. But with SMB transparent failover, we can have multiple network adapters, each figuring out their own path, or each adapter having multiple paths through to where we need to get to. So if any of those connections breaks, whether it's a network adapter, a network cable, a switch, an internet connection or a site connection going down, if there's an alternate path to get through to where it needs to get to, it can figure that out pretty quickly and keep going without interrupting the workflow that's currently happening. So the way that we can set up SMB transparent failover is it's really simple. We just add multiple we just keep adding more adapters if we want more bandwidth, and that's something that is very, very easy to do. So if we take a look at what's happening here, we've got normal operation, which is everything's being written through one server, but it's being replicated across both of the locations. Now, if we lose that initial connection through to foo1, what will happen here is that it automatically auto recovers, and the I/O occurs for that application directly through foo2. So this is something that SMB transparent failover includes, and it's included as part of Windows Server 2012 and 2012 R2. Now, the final piece of the overall story in terms of additional enhancements that have been made to Windows Server that do enhance the whole Windows Server and Hyper-V story is storage tiering. So this is Microsoft providing some SAN-like functionality inside the box with Windows Server. And one of the capabilities that was introduced with 2012 R2 was the ability to start using storage spaces and with tiered storage. So with tiered storage, it means that we've got the solid state drives and the physical drives acting together as one storage unit, but the hot data is automatically being moved up into the solid state drives. Now, it's not looking at this at a file level, so it's not saying, well, this SQL database is frequently used, or this VHD file is frequently used. It looks at the sub-file level to look for the hot portions of the data within the file, and that's where that data actually lives. So we're not talking about copying the hot data from the hard drives to the solid state drives. We're actually moving those portions of the files that storage spaces has deemed need to be in as part of that storage tier. So this starts giving you very, very good performance improvements without having to rely on a huge farm of SSDs to do this. So even as what you might think of as a small SSD cache can actually start performing some very, very large improvements to your I/O and your overall performance on the of storage on the network. Now, if you do have specific files that you always want to make sure are part of that SSD tier, you can definitely do that. You can use PowerShell to pin these files into the SSD tier. But the general recommendation is that, let storage spaces figure out what it needs to do, because if a file needs to be in there, it generally does end up in there, or at least the parts of it that need to be in there are in there. So now let's switch gears a little bit and talk about Windows Server licensing, especially in regards to things like virtualization. So first up, we're only going to be focusing on the first two versions of Windows Server here. So we'll talk about Data Center and Standard Edition in the next few slides. And then after that, the other two options here, Essentials and Foundation, because Foundation doesn't include virtualization rights and Essentials has got very limited virtualization capabilities. We won't cover those in this session. We've covered Essentials in a lot of detail in other sessions. If you take a look at some of the video recordings we've done previously, if you take a look at the blog posts we've done, even stuff around Windows Server 2016's essential capabilities. We've got a lot of information on that up on the OEM team blog for Microsoft Australia. So let's just focus in on Data Center and Standard. So with Data Center and Standard, really the only differences between the two of them are around the licensing and the number of virtual machines / virtual operating system environments that are included. With both of them, a single license allows you to have up to 2 physical CPUs per server. So when we think about the typical server that we're selling to an SMB customer, generally we're talking about a single or a dual proc server. We're not talking about quad proc servers in most SMB organizations. So we'll cover that in more detail and what the impact of that is as we go through some of the next few slides. So then the other piece here is that when it comes to client licensing, the client license requirements are the same across Standard and Data Center Edition, and the CALs, one CAL gives you access to both Standard and Data Center, so no real surprises on that one. So starting with Standard. So your customer can stack copies of Standard. So if your customer says that they want 2 VMs and then they change their mind and say they want 4 VMs, well, you could sell them 2 copies of Standard that are stacked on top of each other. And we've got some diagrams and some discussions of that coming up. But it's one of those things where you need to think about what the long-term implications are. If the customer is going to need, more than a handful of VMs, you really need to have that data center conversation very early on. And hopefully some of the information you see throughout this presentation does assist you with that messaging. So we can go through, we can assign them, we've got the rights to run additional instances of Windows Server, and as I mentioned, we'll go through and explain it in a bit more detail. However, if you've got a customer that's straight out of the gate, you know that they've got very, very high-end virtualization requirements, then you know that Data Center is probably going to be the better choice for them. So the other thing that I nearly always recommend to customers that are looking at buying Data Center through OEM because they're getting it at a good price is just making sure that they are aware that you can add software assurance to OEM server purchases. So that way you're getting the VL plus SA rights applied to your OEM purchase. So speak to your Microsoft authorized disti about this. They'll be able to go through it in more detail, give you all of the terms and conditions, but it's definitely something that you can do. So how do you calculate the number of licenses you need for a server? Well, there are 2 things that you need to take into account. The first one is the number of physical processors in the box, and the other one is how many virtual instances of Windows Server are you going to be running. So the first one, the number of physical processors, well, that's easy. Effectively, for 2 processors, we need 1 license. For 4 processors, we need 2 licenses. For 8 processors, we need 4 licenses. And that pretty much covers most of the workloads we're going to see in the SMB space. Now, what's also important here is that with Server 2012 R2, when we talk about CPUs, we are talking about physical processors. We don't care about how many virtual CPUs are inside of those. So it could be single core, dual core, quad core, hex core, octa core, etc. It's really up to you to basically just sell the right CPU performance for what the customer requires. Then the second part of it, for Standard, you need to figure out, well, how many virtual operating system environments do you need? And then you divide it by 2 and round it up. So we'll cover this in the next slide, so don't worry about it too much yet. For data center, it's easy because we've got an unlimited number of virtual operating systems we can, or virtual operating system environments for Windows Server that we can run on each server. So that effectively means that we can basically keep scaling up until we've tapped out the server hardware that we purchased. So obviously, if I've got a server with 128 gig of memory, I'm going to be able to run a lot more virtual machines on that than I'd be able to run on a server that's only got 16 gigabytes of memory. So these are some of the things that you need to take into account when you are factoring in the cost of the hardware and the software, making sure that you do get that right mix and make sure the customer does get the right version of Windows Server. So this is a very simple table, but it explains, if the customer stacks. So in this case, you'll see that if they stack up to 4 licenses of Windows Server, they get 8 virtual machine rights. Now, this is a scenario where generally I'd probably steer you away, definitely from the 3 and the 4 type scenario. At that point, you've probably already gotten to the stage where data center purchases start making a lot more sense. But this is just an easy to look at table where you can figure out the maths. You basically take the column on the left, multiply it by 2, and you get the column on the right. Now, if we take a look at the stacked Windows Server here, okay, if we take a look at the licensing implications of the bottom of the diagram, where we see the 2 Windows Server licenses running on a dual proc server, then we can see here that we've got 4 VMs. So the 2 licenses times 2 VOSEs each, that gives us 4, and the customer is compliant here. So no questions whatsoever on that one. Now, as we move across the data center, what you'll see here is that we've got 1 license, the 2 virtual CPUs, and the customer's only running 6 VMs at the moment. But if they wanted to run 10 VMs, if they wanted to run 20 VMs, as long as their hardware could cope with what they wanted to do, there's no problem whatsoever with doing that. So some of the frequently asked questions we get around the rights for service standard versus data center. Some of the ones we get most frequently. So can I mix data center and standard licenses on the same server? So no, you can't do that. So if you're stacking standard licenses, they all need to be standard. And on a server, if you need multiple data center licenses because it's a quad processor server, that's where you would need to make sure that you do have 2 data center licenses, for example. Can I use a standard license to cover a single proc server? Yes, you definitely can. You don't need to have 2 procs to use standard. I think you all know that one, but sometimes we do get variations of that. And that one, though, generally ties into, well, if I'm only using 1 processor and 1 VM, could I split that and use it across 2 physical servers? No, because you're licensing it per physical server, not for the ability to split capabilities out across virtual servers, across multiple servers. And then, can I assign a Windows Server 2012 R2 license to a virtual machine? And no, you don't license the virtual machines. You license the physical servers for the number of virtual machines and physical processors that they've got. So so don't think about it in terms of licensing the VMs. Think of it in terms of you're licensing the hardware that it runs on. So let's now take a look at a couple of different scenarios that some of these will be familiar, some of them may be a little bit different to the types of things you've done in the past, but it's worth taking a look at these to think about what the implication is around your licensing requirements here. So if we take a look at high availability and recovery scenarios, well, generally if a customer is looking at building out a clustering solution, generally Hyper-V with Windows Server Data Center is going to be what they are going to be looking at here. So generally it's a fairly easy conversation. However, with Live Migration and Hyper-V Replica, one of the things you really need to take into account with this is you need to plan for a worst case scenario from a licensing perspective. So if you've got 2 Hyper-V servers, each of them running 4 virtual machines because you've purchased 2 copies of standard per server, what you have to think about is, let's just say you need to take server A offline for hardware repair, etc., 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 and the second server needs to run all 8 of those VMs. It's not actually licensed to run 8 VMs. It's only licensed to run 4 VMs. So you need to think about, making sure that, for a worst case scenario, you're actually covered. And this is where data center licensing really starts giving you a lot more flexibility. And if you add software assurance to it, that really starts giving you a lot more flexibility around the mobility side. Now, other scenarios that can affect customers' requirements, this slide is a bit of a different take versus what you may traditionally think of. So when you traditionally think of virtualization in a Windows Server environment, you might be thinking in the past, well, we may have virtualized the Exchange server or the remote desktop server. We'll make sure that Active Directory is virtualized. But with the adoption of different cloud technologies, there are other things we can start extending back inside the network from our cloud providers. So while many of us may have said, oh, look, we'll just move across to hosted email, it's a lot easier, someone's handling all that work for us. But then there might be scenarios where we start saying, well, we want additional capabilities that cloud services provide, but extending them back on-prem. And I did a big post on this up on the blogs.technet.com/Oz OEM team. So I'd say take a look at that. There's a lot of detail around these types of things explaining these scenarios. But when you think about it, if you kind of borderline between standard and data center in terms of pricing, in terms of the overall solution, generally I'd say from a future looking perspective, data center probably is going to make a lot more sense. But take a look at some of the scenarios that have been posted over the last 3 to 4 weeks, and you should see some good information that will help you have those conversations. So in terms of upcoming events, probably the big one that's happening in the next month is the Microsoft Cloud Roadshow in Sydney. So this is a 2-day event that covers a whole bunch of different technologies, on-prem, cloud-based, Office 365, Azure, Windows Server. So take a look at that. It's cloudroadshow.com/Sydney. So yes, that one's only a Sydney event. But hopefully some of you from interstate are already thinking about attending that one if possible. And then to wrap up, just in terms of resources, you've got the 3 primary ones that we've got here from Microsoft Australia OEM are smarthq.com.au, the Australia OEM team blog site at blogs.technet.com/OEM team, and then we've got our pre-sales information for OEM server products, which is OEM Server AU at Microsoft.com. So get in contact with us through any of these means. There's several of us who manage and maintain these. So keep in touch. Let us know the topics that you'd be interested in hearing about in the future, and we look forward to hearing from you. So thank you very much for joining us on the call.